All right, so at this point, as I said, we want to do a formal introduction of the topic Internet of Things. It's something that we are also working with hands-on, and that's basically what we talked about in the last, well, in the first segment of this session, where we presented the user stories that you thought about. These are all more or less involving this concept Internet of Things, and we want to get a picture of what is meant by that, and then also look at use cases that we find in practice and technologies and related topics to that broader field. And we start with a definition. As often, a definition gives us a good picture of what we're talking about. And here you will find different definitions of the term Internet of Things. But I think the important parts are highlighted here. So the Internet of Things, or also abbreviated, you will often find the term IoT. And even when people speak, they often say IoT, and that's Internet of Things. It's the internetworking of physical devices, vehicles, buildings, and other items embedded with electronics, software, sensors, actuators, and network connectivity, which then enable these objects to collect and exchange data. So the main idea here is that physical devices, and here are some examples, it could be vehicles, buildings, or any machine, could be a greenhouse, could be an office building. So anything from the physical world is equipped with smaller devices like sensors or actuators that do different things. So sensors are taking something from the environment. As the name suggests, they sense something. So they, for example, measure temperature or detect motion and stuff like that. So they can measure something from the environment and transform it into a digital form, into a digital representation. And we talked about that in the last session. And then we have actuators, which are the opposite. Basically, they put something, or they act, as the name suggests, in the environment. So this could, for example, be a servo, or a motor, or the motorized linear polybricklet, or some switch that turns on a light, or some other device, so something that interacts with the physical world and does something, performs an action. So this is two classes of devices that we often find in IoT, so sensors and actuators. But of course, there's more to it. There's software. There's the software that we need to write that controls what to do with the input from the sensors and what actions to perform using the actuators. So there's always software involved, and then we usually also have network connectivity. So we don't just want to have one device that collects information about the environment or that does something to the environment, but usually there's a network of devices that communicate with each other, and therefore we need some form of network connectivity. And using this network, these devices can then talk to each other or exchange data or information, and of course collect data and information. So that's the whole idea, equipping the physical world with the means to interact or to communicate using the digital world. And so, of course, this is all about, as you might imagine, trying to extend the idea of automation to a broader range of use cases. Because once you can not only automate things that are purely running in a computer, like we did before, or like we always did. So we can write an algorithm and then run that algorithm in a computer, and it's purely automated. When we have the physical world, we usually need some form to interact with the physical world, and that can be a human who pulls a lever to turn a machine on or something like that. And we try to remove that human basically from the loop. So we want to have smart devices, as I said, equipped with these sensors and actuators that can then, based on the software that they run, act more or less autonomous and exchange information, talk to each other. So we have less humans in the loop, actually. So then you may often find or hear the term Industry 4.0, which is something that we, it's also a broad broadly used keyword, and often it's interchanged, or you hear it in the context of IoT or Internet of Things. So what do we mean by Industry 4.0? And to say this up front, Industry 4.0 is a concept or an idea that's much bigger than the Internet of Things, and it's much bigger because Internet of Things is actually one part, one crucial part though, but one part to this concept of the Industry 4.0. And so if you want to understand what the Industry 4.0 is, what we mean by that, and it's again a very foggy term, it's used differently by different people, but generally we can say that we mean like a collection of technologies that we apply in today's industrial processes, mainly to enhance automation and to work more effectively. But to understand that, maybe it makes sense to quickly look at the other industrial revolutions that we had. So if we are now in the fourth, or Industry 4.0 means that it's the fourth industrial revolution. So what were the others? And I'm sure you all know that from history lessons, but let's briefly go through them and look at the technologies that have been invented and used during these revolutions. So the first one was the Industrial Revolution starting in the mid-18th century, where the steam engine was invented. So the steam engine, I'm sure, as you all know, replaced human muscles with mechanical power. So we were now not just able to use our own muscles, for example, on the field, but also generally working in different areas. Now we can apply machines to do that. And the steam engine was one way how we could use coal power to translate that into mechanical power, and that would give us much more power, and we can now have whole range of new applications that we can tackle with the steam engine. And for example, of course, the railway and the trains are one of them, as the icon suggests. So the first industrial revolution was then followed by the second by the end of the 19th century, where we invented electricity, and we also were able to use gas and oil as energy sources, and that led to new benefits. So now we can distribute the energy using an electrical grid, basically. So before, when we had the steam engine, a factory, for example, or a place where we wanted to apply steam power would need such an engine, which is quite heavy equipment, right there where the production or the manufacturing happened, or basically where the energy or the power was needed. And with electricity and so mainly with electricity, we now have the means to distribute energy across, as I said, for example, a power line or an electric grid. And that gives everyone the option or the chance to use that energy, and that, of course, powers creates many new use cases and many new chances for different applications. So, for example, also in this time, the internal combustion engine using fuel as an energy source was coming into place and was used in more and more use cases. And a typical association we have with the second industrial revolution is the assembly line, where we were able to become much more efficient in our manufacturing processes and use, as I said, for example, electricity across a whole new range of applications. So then the third one is often called, let's say the invention of computers and digital electronic devices is often called the third revolution, which started in the mid-20th century, around 1950, when the first computers were built. So the first ones were invented then, and they were then more and more used the time after that. And that was, of course, a big step, because now we were able to digitize things, and we were able to use software and computers to do calculations for us and perform many tasks much more efficient, and do complex calculations that we couldn't do before, and also perform operations on larger amounts of data than we could before. So in the same time, we discovered nuclear power to be used in a broader sense. So we have a new power source, and also with computers, we could now do other things in biotechnology, for example. The sequencing of a genome started later in this revolution. So this was all powered more or less by digital computers. And this is what we often associate with the third industrial revolution. And then if you look at the fourth, which is basically what we mean by Industry 4.0, as I said, there's often different definitions of the term, but basically what we mean is that we now have, in addition to the digital computers, we have a lot of digital technologies that we can make use of. And one of them, starting in the late 20th century, was the internet. And the concept of cloud services, which followed at the beginning of the 21st century. But we also have IoT, so the Internet of Things, small devices that are interconnected, that allows machines and general physical equipment to be communicating and to sense and share information, and also to act autonomously. And with that, we get other, I wouldn't say technologies, but other trends like big data. We now have a data explosion, which is simply powered by the more and more digitization of processes and everything related to that. So services, products, and stuff like that. So we have a lot of data. As I said, we often refer to that as big data or data explosion. And fueled by that is the topic of artificial intelligence. So we see the combination of powerful computers and cheaper computers. So computer hardware gets cheaper and more powerful at the same time. And parallel to that, we have the data explosion, which both is a prerequisite for artificial intelligence to work, because artificial intelligence, as we will learn later in the semester, relies upon the availability of data. And so this is one mega trend, one technology that has recently, in recent years, gained a lot of attention and enabled a lot of new use cases, and that is also part of the fourth industrial revolution. And then you could also subsume something like virtual or augmented reality, which enables also in the industry new use cases where you can have 3D virtual worlds, and you can have a mix of the real world and some virtual elements in augmented reality, and this enables also a new level of use cases and a new level of efficiency in the end. So this is basically what we often refer to as the fourth industrial revolution. And when you hear Industry 4.0, it's often about the automation in the industry, in manufacturing mainly, where machines become smarter and equipped with sensors, actuators, sharing data, and thereby being able to automate more and more and taking the human out of the loop. And all these technologies that are listed here are somewhat related to that Industry 4.0 term or idea, and they all play a role in the fourth industrial revolution. So that's just a brief review of the other revolutions that we had, and as I said, now we're in the fourth one. And people often argue which technologies are actually part of the fourth industrial revolution, but I think these which are listed here are more or less clear, but there's of course more to that, and also for the other the first, second, and third, there's of course much more that happened during that time. So that's just the most important, or some important key technologies that were invented, but there's of course many other technologies that followed these inventions and that are also very important, but for the sake of simplicity and space, I only put down the most important ones. So let's look at the Internet of Things, because that's the topic here. What do we mean by that? And very simply put, this is an example of one of the first commercial IoT use cases on the market, which was by Nike Plus. They had a shoe and they put a sensor in the shoe, and that's depicted here. So you have a thing, and in this case, it's that thing is a shoe, and then you add a sensor to it, and that's basically what the first step in an Internet of Things application looks like. So you put something a sensor to a real device. So we could also take another thing like this is a plant that and it's put into a I don't know the English word, top. And then we add a sensor, and one of you, I think, also had the use case with the moisture sensor, and this would be an example. So you put a moisture sensor into such a plant, and what you get is, in the end, the information from the sensor. So it senses something from the real world, in this case, the moisture in the soil. And the idea of Internet of Things doesn't stop here. So the question now is, what do we do with that information, and why do we even measure it? And of course, the idea is that we have some use for that information, and the use for that information could be to control something in the real world. So we sense something, and based on that information, maybe plus some other information, we are going to control something in the real world. And we do that here in the example using an actuator, and this is depicting some sort of switch. It's a relay that, for example, could turn on a watering system, and the watering system then puts water to the soil, to the plant, which in turn is measured by the sensor, and the sensor then would update its information about the real world, stopping in the end then again the actuator from putting more water into the plant. So that's a very simple circular application where we actually don't have a human in the loop anymore, because everything is automatically controlled. We have the sensor and the actuator, and they share information, or the sensor shares information with the actuator, and that again affects the real world, and the sensor gets new information. So we said that connectivity is an important part in Internet of Things, and we usually don't have only just one thing in a system. We often have more than one thing or more than one device that is somehow interacting or is part of the system, and therefore we need some way for them to communicate if they need the information from another device. So in the example of the greenhouse, there was the actuator. If it's a different device, then we would somehow need to be able to share the sensor information with the actuator or the system that controls the actuator. And we do that by connecting them via some means. And we want to briefly look at some of the options that we have here. And if you imagine that here are three things that are put in the same environment, or you can imagine this is a room, like an office or a greenhouse or a factory. And one way to connect these different things to each other is using an access point for Wi-Fi, and they could all be Wi-Fi enabled. And so through this access point, because they're all connected to that wireless network, that would be one way to exchange information and to exchange data. And that is something that is often done in a smart home environment, where you have a Wi-Fi, and these things are connected to that Wi-Fi and share information using that Wi-Fi. But this is not the only means to do that. So there could also be a direct peer-to-peer connection between two devices using, for example, Bluetooth protocol. And that is also something that we often find, for example, when we use running equipment to measure our heartbeat or something. They often use Bluetooth connected to our smartphones. And through this Bluetooth connection, we exchange the information about the heart rate with the app that's running on our smartphone. And I'm sure you have more examples in your head. So Bluetooth is a very widely used protocol. So the problem, or I wouldn't say problem, but one thing you have to know is that Bluetooth is not working across larger distances, while Wi-Fi can be used in a larger environment. Bluetooth is usually limited to a couple of meters distance. So, but there's also, of course, there's other technologies. These are all wireless. You can also use cable, of course. You can connect devices by cable or other protocols that can exchange information. But there's one other aspect to it, and that's when we go to the actual internet. So this is all the Bluetooth and the Wi-Fi can all happen locally. We do not need any global infrastructure like the internet for it, but we can do that, and often it's done because we want the information of our things to be spread across the globe, or we want to use a cloud service to process and store our data. And then we need some connection to the internet. That could either be the access point that's establishing that connection, but it can also be the thing itself, which can be equipped with a SIM card, and the SIM card can then make a direct connection to the internet and, for example, share information with a cloud service or store something on a server. And if you look at a more global picture, if we have now, for example, 2 different factories or 2 different greenhouses, then we could look at them like this. So we have one on the left and one on the right, and in between they exchange information using Wi-Fi or Bluetooth. But if you want to connect both and exchange information and maybe have for example, a global dashboard or control system where we can control more than one greenhouse, then we would connect them using either the internet or an intranet, which is basically a subnet for a company or something like that, which is using the same physical technology like LAN cables and stuff like that, but it's not visible to the outside world. But we could also use the internet, of course, to establish a connection to a cloud service or a server and send information there and have a dashboard access that information. And that I already mentioned, often we use cloud services for that. So there's specialized products by large vendors like Microsoft, Amazon, and Google. So every one of the large cloud service providers today offers solutions specifically for IoT management and IoT, so managing IoT devices, managing the data from IoT devices, and then doing something with the data. So there are solutions offered in the cloud to help companies do that. And of course, you can imagine in our simple use cases, we have maybe a handful of sensors, but in a industrial setup, for example, in a manufacturing site, you can have thousands or tens of thousands of devices and sensors, and that becomes a management problem. So you need to somehow be able to manage that strategically and in a structured manner, and then you can use such cloud services to do that. And they help you do that. And so that goes, of course, not just for manufacturing, but even if you have a greenhouse, there can be easily a couple of hundreds or thousands devices if you have a large one. So that becomes also a problem at a smaller scale. And then you need to think about how you manage the large amounts of data, how you manage the devices, how can you remote control devices. And these are all questions that are addressed by these service offerings in the cloud. So let's look at some of the technologies that are typically found in an IoT environment. And this is not an exhaustive list, but it's to give you an idea of some of the important technologies. So one is RFID. RFID, I'm sure you've heard before. It's similar to NFC, which we'll look at in a second, but it's basically called radio frequency identification, which RFID is short for. And the idea of RFID is that we have small chips, RFID chips, and they often come in the form of a sticker, like you see here. So this is actually a sticker that you can attach to, for example, a food product, but it's often found in logistics where you put it on containers or boxes. And the idea is that you store a small amount of information on this chip, and it allows you to do that, but it's really a small amount. So you can write to them, and then you have RFID readers who can read this information from a short distance. So depending on the type of chip you have and the type of reader, these distances can be a couple of meters or just a couple of centimeters, depending on, as I said, the type of chip, whether they have their own power supply or they are rather passive. Then it's just a shorter distance. So, but the idea is you store a small amount of information. For example, the product number or some information about where it should be stored. So small numbers like an ID and little information you can store on there, and then you can use that to automatically identify, for example, if you scan such a RFID chip and it's on a food product, you could, for example, have automatically the information when it's no longer to be consumed. So the date when it gets bad. So it's used a lot in logistics. For example, if you go into our library at the university here, it's being used to check out and return books. So in every book you will find such a chip in the form of a sticker in the back of the book, and when you put them into the reader, basically the device where you put it in when you return it, it reads the RFID information and will automatically book the book back into the system for you and update the record so it knows that you brought the book back. So this is RFID, and then NFC, in contrast, it uses same or similar technology, but it's called near field communication. It works only from a very short distance, and I'm sure you're all familiar with use cases. So one of them is depicted here when you pay with your phone, which is becoming more and more which you can do more and more in different stores. This is using NFC, and of course the contactless credit cards, and they also use NFC. So when it's basically the same technology, the reader doesn't distinguish between whether it's a smartphone or a Visa card. The technology is the same. It looks for an NFC signal or an NFC chip and then reads this information. So you can also just as with RFID, you can store small amounts of information, and then of course, if you have two devices that support NFC, you can create a peer-to-peer connection and exchange information. So here, for example, access to buildings, your campus card that you have from the university is NFC based. If you access a building with it, I'm not sure if we actually have a use case where we access buildings with it, but we could. I know at the university here it's done, but when you pay in the cafeteria, it's also NFC. I'm sure you have done that before. Contactless payment, or if you have a handshake between smartphones, that's often where we use NFC as well to exchange contact information and stuff like that. And this is one of the devices that we can also use in our applications that we're building here, because we have NFC readers, we have NFC cards, and we also have NFC stickers. So if you have a use case where you want to put stickers on a fake product or something, you can do so and play around with NFC. By the way, so this is what an NFC reader looks like. So it's basically you put the card here, and I'm sure you never see them in practice because they're usually put into a product and there's something around it, but basically they are just an area where you can put the NFC card or the sticker, and then there's the reader that tries to get the information from that other NFC, where you store the data. So then sensors, I think we have talked about them. And it should be clear what we mean by that. Basically, something that converts an analog to a digital signal from the real world. So for example, temperature or light, or humidity, sound. That's all that we can, these are all different types of energy that we can measure with sensors. And these enable our devices to collect information about their environment. And sometimes that's necessary and important. For example, when we want to detect motion, we can equip any device to do that with a motion sensor, and it gives the device to automatically detect people or anything coming into a room, and thereby we can automate processes that should follow when somebody enters the room. And this is the same for any other sensor, and you already have presented very good examples of how you want to use sensors in your own applications. And here are just some examples of sensors that you can find, and most of them we can also use in our applications. Actuators is basically the counterpart of a sensor. It's acting in the physical world, so it's not sensing something, but it's rather doing something to the environment. And an example is to turn on the watering system when a plant is dry. That would be some form of a motor that is turning or is opening or closing a valve, or turning on a switch, turning on a relay, robot arms or motors. So everything that can perform an action in the real world, we call an actuator. And there are some of them we can also use in our own applications, but most of them, for the sake of simplicity, we will simulate using our website, where we just simulate as if something was watering a plant, and we depict that by, for example, a small animation or an icon that turns into a certain color. So we have seen in the definition that there's not just the devices, but also software, and software can be in the form of a JavaScript program that we are writing here, which is based on a web application. But if you think about devices that are not having a web interface, but that are rather small embedded devices, we need something different. And there's, for example, the Raspberry Pi that is a small computer that you can tinker around with, that we could also use in this module, but we are now not building something physical, but we are using our web interface, so we don't use them this semester, but we could. And there you need specific hardware, and they are often referred to as embedded software, specific software, and they are often referred to as embedded OS. OS stands for operating system. And the idea is that if we have small devices that control our IoT solutions, we want to have devices that use little power and that usually have also less hardware equipment and computing power and memory, because we want them to be cheap. We need thousands or millions of them, so we need cheap devices. And so they are usually low power and low memory, and we need special software which can run on these limited devices. And these are examples. So Raspbian is typical on a typical operating system on a Raspberry Pi. There's Windows 10 IoT edition, which is basically a Windows 10, but a very, very small one, or a very lean system, which only has the necessary components to run IoT solutions. And there's also Android Things, which is the answer from Google to embedded systems and embedded operating systems. So there are different operating systems that we could use. Just so you know, they exist. We don't use them here because we use actually not such a low power or low memory device. We use our laptops, and there we can have fully featured web applications that run our software.